Hi everyone, in this video we are going to be learning the underlying architecture of AI agents that can go from a simple text prompt to an executed task on your computer. So if you're interested in learning how computer using agents work under the hood, let's jump straight into it. And I'll start with a demo. So this is the task, and the task is to go to the Leon Petrie YouTube channel and get the name of the most popular video on the channel. That's all you need to do. Then you just need to simply run the script and watch what happens. So we can see now it's opened up this browser. I'm just zooming in a bit. All right, notice how it identifies all the user interface elements on the screen. It typed Leon Petrie YouTube on Google. It then clicked on the first link. Now it's identifying all the other elements. Now it's probably going to click on the popular tag. There you go. It's filtered now by popular, and it should then scrape the title of my most popular video, which is a Transformers video. So looking at the output of cursor, we can see it went through all these different steps. All right, it searched for the channel, opened the YouTube link, clicked on the popular tab, and then it completed the task. And then you can see the result is over here. The most popular video on the YouTube channel is Transformers Explained, Understanding the Model Behind ChatGPT. And how amazing is that? We didn't have to pre-program any of those steps into the computer in order to tell it what to click or what to do. This was actually powered by an AI language model, in this case GPT-4o, and it was able to go and execute all those tasks on its own and give us the answer in a matter of seconds. And this can be applied to any task you do in your browser. You simply just type in a text instruction and then it completes a task for you. So of the computer using agents that are currently available on the market, we have under the closed source computer using agents, we have OpenAI Operator, which is $200 a month. And then we have Claude Computer Use. That's currently free, but it's still in beta. Once that's ready, it will be a paid product. And then in the open source category, there's one called Browser Use, and Lavag is another one. Both of these are really good and they are completely free to use. All you need to pay for is the API credits for whichever vendor you're using. So if you're using OpenAI, you just come here to create a new key, you'd give it a name, and you generate an API key that you can use, and then you'd be billed based on your usage, and there will be no monthly fee. So the explanation I'm going to follow for this video is based on browser use. All right, so I basically went and downloaded the code from GitHub. So this is browser use. I basically came here, followed this quick start installation, and then I basically cloned the repository. And that is how I was able to use browser use on my machine. So what OpenAI, browser use, and Lavag all have in common is they're all browser-based computer use agents. It's essentially a browser use agent. And that means it's interacting with the actual code in the browser in order to identify interactive elements and click on them and type into them, etc. However, with Claude Computer Use, theirs works a little bit differently, where they use the actual pixel position left and right from a screenshot, and that's how they identify what to click on or what to type into. So what I'm going to be explaining in this tutorial is how browser use works, since it's the more common approach to computer using agents. So there's three core components to any computer using agents. There's the browser, the agent, and the controller. So the browser is basically a controlled web browser environment. So it's a separate browser to the one that's maybe currently open on your machine. It can work with either Chromium, Firefox, or WebKit. Chromium is browsers like Google Chrome or Microsoft Edge. Firefox is Mozilla Firefox, and WebKit is Apple Safari. Then we have the agent, which is the brain behind the model, which is a large language model. With the open source models, you're able to plug in any third-party large language model and use that one. So for instance, you can use GPT-4o from OpenAI, Claude 3.5 Sonnet from Anthropic, DeepSeek v3 from DeepSeek, etc. Ideally, you want to use the smarter models because computer use is quite a challenging task. So you want the smarter models to be able to be smart enough to know what to click and how to interact with the browser. Then we have the controller, and this manages the interaction between the agent and the browser. All right, so there's a few different ways to do this. The way browser use does it is they use a framework called playwright.dev. And Playwright is basically a testing framework. So these testing frameworks are usually used when you want to automate a browser to test an application as if a user would do it, but you kind of want to automate these things, and that's why these frameworks like Playwright exist. Another one is Selenium. That's what Lavag uses. And there are also some other test automation frameworks. So this is the computer using agent architecture. So we can see it starts with an instruction. It then gets fed into the get browser state. And this extracts the context from the browser. So basically, it extracts the code, the text that's on that page, as well as a screenshot. Once you've got that context from the browser, it then moves on to run the actual agent. And what happens there is it evaluates the previous step, and it also then predicts the next step. Then after that, it actually executes actions with the controller. So the controller, in this case, we're going to be using Playwright, and that's what is actually used to click, type, and scroll, etc. on your actual browser. From there, it makes a decision, does it need to continue to the next action and continue the loop, or does it end? And then from there, it displays a result or the task is completed. So that is the simplified architecture of computer using agents. So I'm going to go through each of these step by step so that you can understand how these AI agents actually work under the hood. We'll start right in the beginning, which is the instruction. And that is basically when the user types a prompt and then clicks run. Okay, so in our case, it was go to the Leon Petrie YouTube channel and get me the name of the most popular video on the channel. This could be any instruction that you would usually do as a human and you'd execute within your browser. As long as you provide enough details and information in the prompt, it will be able to navigate and execute that task. Next, we have the get browser state. So step 2, once we've provided the input, is browser scraping. So this is required because it provides context to the large language model input, which is the agent. This includes basically the text, code, and screenshot that's extracted from the browser to get the current state. And this does not use a large language model. This uses traditional programming functions to scrape and extract that text, code, and screenshot. All right, so the stuff it scrapes is usually the URL, the title on the page, the element tree, the tabs, and the pixels. So just to elaborate on each of these, the URL is the URL of the current web page that's currently open in the browser. The title is the page title. So if you hover on the tab, you'll see the name is Computer Using Agents in a nutshell. All right, then we have the element tree. This is a structured representation of the document object model. So if you right click on the page and click inspect, all this code, that's basically the document object model, but it doesn't scrape all of that. It's not the raw HTML. It's usually a simplified tree structure that includes relevant elements and their attributes. Then it also scrapes the other tabs available. So it'll scrape all these other open tabs that are currently open, and then pixels above and below the current page view. So that determines whether the page is scrollable. So it'll count the amount of pixels that are above or below. Then the agents will know, can it scroll up or can it scroll down based on if there's pixels above or below. So that's what happens in step 2. It scrapes all of these details from the web browser. Step 3 is then using that element tree or the DOM. It then generates a selector map. So what the selector map actually is it's basically a filtered down version of that element tree where it only includes the interactive elements on that web page. Stuff like buttons and input fields and scroll bars, etc. The way it determines this is it basically does a search for the attributes on all of these elements. And if it can find attributes such as button, link, checkbox, radio, slider, scroll bar, search box, etc., then it knows that that is an interactive element. And it basically then returns what you call a selector map, which is a JSON dictionary. It's got a list of all those interactive elements. So you can see on index position 0, we have a button. It's got some additional details like the class and the ID of that button. And then this is the most important part, is the X path. And this is basically the selector or the code that navigates to that specific interactive element on the browser. So that's how you know what to click on, what to type into, because that represents the actual button. Then we have index number 1, and then it'll continue to index number 2, etc. This JSON structure is able to be parsed, and you can extract the relevant values and use them everywhere else within the model. And I'll show you that in just a moment. So step 4, once it's generated the selector map, we now take a screenshot of the browser. You are able to visualize the interactive elements with the index labels on the browser. So you can see here highlighted, these are all the interactive elements. So you can see like my name there isn't highlighted. That's because it's not interactive interactive. It's not a button. You can't click it. But you can click the subscribe button. Well, while we're here, why don't you subscribe to the channel if you're enjoying this content? Then we have all the other interactive elements like these actual videos which are clickable. We've got the names which are actually clickable, etc. So how this works is it takes the interactive elements from the selector map and it highlights, labels, and colors them with JavaScript using the selector for each interactive element. And then it takes a screenshot. So some language models are not multimodal. Claude 3.5 Sonnet and GPT-4o are multimodal at the moment. DeepSeek currently isn't. It uses OCR to actually scrape text from an image, but it's not actually multimodal. So with these open source models, you can either enable or disable vision, but ideally you want it enabled because what this screenshot will do is it'll apply additional context to the language model when it needs to make a decision on what to click, because it can actually see these little numbers. I'm not sure if you can see that, but if you zoom in a bit, you can see there's numbers over there, and those are the actual indices. Remember what I showed you earlier, this 0, 1, etc. So it'll start from 0, 1, 2, 3, 4, 5, 6, 7, etc. So that's the actual index position of the interactive elements. The next step is now to run the agent. And what the agent does is it evaluates the previous step and then it predicts the next step. So how this works is the large language model takes the initial instruction prompt as input, which is what the user typed in the beginning. It also takes context of the previous steps, right? And I'll show you what those are in just a moment. And then it determines what the next action to take is. It's just guessing what the next action is because this is powered by a large language model, which means it can hallucinate. So there is a possibility that this agent will break or not do what you want. But as these large language models get smarter, the computer using agents will become more useful and capable. Then the response from the large language model is a JSON object with actions to take. And this can either be just one action to take, for example, going to a URL, or it could be a sequence of actions, for example, typing in the input field and then clicking the search button. So the large language model will take in many different inputs, and these are the inputs that are gathered from the browser scraping as well as from the user input. So the user input is the task, the initial instruction. It takes as input the system instructions, which is stuff like the role, the response format, the instructions, etc. So if you're curious what that looks like, so here's the system prompt. You are a precise browser automation agent that interacts with websites through structured commands. Your role is to analyze and provide web page elements and structure, plan a sequence of actions to accomplish the given task, respond with a valid JSON containing your action sequence, and state assessment. And then you can see they do some what you call answer engineering, which is basically, it's a concept in prompt engineering, which is how to structure your output. And it gives an example of the JSON structure that it wants, which is that over there. So I'm not going to go through this whole large language model list, but you can see that is basically all the inputs that it takes into the large language model so that it has enough context so it knows what step it needs to predict to do next and what actions to take. So here I just provided a little example with the LLM input where in the user message, it takes in the initial instruction, and in the system message, it includes the response format, which is what I just showed you now. And then the output would be a JSON structure or JSON dictionary like this. It'll contain the key current state, then the key evaluation previous goal, then memory. The value in this case is empty because it's the first step, so there's no memory that it has. Then it has next goal. Then the next prediction is open YouTube and search for the Leon Petru channel. So that's what it wrote as the first step that it needs to do. And then the action, and this is where it generated the action that it actually needs to take, which is the open tab and then the link that it needs to go to. So a lot of magic is actually happening here in this action, and I am going to explain how that works in the controller section. Just to look at the logs, you can see when the agent finishes running, and you see it's the agent is busy logging all of these. It then logs this action over here, which contains that JSON dictionary for the action that it needs to take. So this is the first step. In this case, it's telling you to open the tab. In this case, it's telling you to click an element. And you'll notice in different types of actions, they have different types of parameters. So in the opening of a tab, the parameter is a URL link that it's going to just navigate directly to a new URL. Whereas for the click element action, the input it requires is the index position so that it knows which exact element, button, input field or whatever that it needs to click. You can see after the agent, it is now the controller that takes over. And that is what we have here. And the controller executes the actions. All right, so that's whether it's clicking, typing, scrolling, etc. The way this works is there would be a file which would contain what you call an action registry, and this will be a whole bunch of functions. But basically the actual registry is a list of available actions and the parameters that the controller can take, and it's referenced by the large language model when it needs to determine what action to take. So basically this whole list would be included inside the prompt so that the AI has context. Okay, these are the different actions that I can take, and these are all the different parameters that are required to actually execute that action. So you can see there's actually not so many of them. There's search Google that requires the search query as input. There's go to URL, which would require the string URL. Go back, that would just navigate back in the browser. Click element, that'll click an element. I won't go through all of these. I'll just go through the important ones like input text. That's basically the field you'll type into. Another important one is this done. That'll actually end the entire task. So when the AI decides the task is completed, it actually calls that done action. All right, so basically this is how the controller actually performs the command on the selector. The large language model would respond with a JSON structure that would look something like this. It would basically be an action JSON, and inside that it would contain the name of the actual action from the action registry. In this case, click element, and you can see it's an exact match as this click element. And then the parameter required for this was the index position. So you can see the index is index position number 33. So this JSON is returned by the large language model. Then that JSON gets passed. It then extracts the selector based on the index. Remember, we had the selector map generated during the browser scraping section. What we are then able to do is reference, okay, index number 33. Here is index number 33 in our selector map. And then from there, we will be able to actually access the selector of that user interface element, or also known as the X path. And then we use playwright commands to actually execute these tasks. Remember, playwright is that testing framework that automates web browsers. What it then does is it then calls the click element action in the playwright command, and then playwright would actually then click on that button. In this case, it's going to click on this button over here. So you can see there's a whole bunch of playwright commands. There's done action. When done is called, remember over here, we had done. If that one's called, it runs this playwright command. If go to URL is called, it runs go to URL action. So that's basically how the language model actually knows which elements to actually click on and how then it actually gets performed by the controller. Next, the language model needs to actually check if the task is done, or else how does it know when to actually end, right? So that's what happens in this decision over here. What it does is it checks if the maximum amount of steps is reached. So you might have seen earlier in the LLM inputs, there's one called max steps, and that's the maximum number of allowed steps. Each step that the agent takes adds one to the step count. And this is there to protect you in case the agent gets caught in a loop, or maybe it's going down the wrong path, to make sure that it doesn't exhaust your billing credits through the API key. So basically, this is how the check is done. It's if the current step number is greater than the maximum amount of steps, then it proceeds to end, even if the task is not completed yet. This isn't handled by the LLM. This is actually handled programmatically. It counts the number of steps as they get executed. The decision that's made by the LLM, though, is when the task is actually completed. So basically, taking all the context that we had from scraping the browser, as well as the screenshot, within the user message, it has an instruction which says, if you achieved your ultimate task, stop everything and use the done action in the next step to complete the task. If not, continue as usual. So what would happen is if the LLM interprets that the task is completed based on what the original instruction or the original task was, it then will return this JSON, which includes done in the action. And it'll also include the result. And then what would happen is it would trigger the playwright command. In this case, it would be the done action. It'll then handle that gracefully and the program will come to an end. So the task will end if the max steps is reached or if the task is done. It'll then move down to yes, and it'll display the result. If the max steps is not reached and the task is not done, it'll move down the no path and it'll loop back and it'll go and scrape the browser state again, and it'll extract all that information. It'll generate a new interactive element list. It'll generate a new screenshot, etc. and it'll run through this whole state. It'll run the agent again to predict the next step, and it'll then execute that with the controller. It'll come make the decision, and it'll keep running in a loop until the task is actually done, and then it'll move down the yes path, and it will then display the result. So you can see if a scraped text response is required, it will return it to the user, in this case via a log message. So we can see the responses. The most popular video on the Leon Petrie YouTube channel is Transformers Explained, Understand the Model Behind ChatGPT. If you're interested in watching it, I'll link to that in the top right-hand corner. It's actually quite interesting to learn how these language models are able to predict the next token. And that's what I explain in detail in that video. And that is computer using agents in a nutshell. If you do want to watch that Transformers video, it'll be showing right now on the screen. If you want to see more videos like this, please do subscribe to the channel, and I'll see you in the next.